viewers, this is me Rikila Srijesh from Zero Wave. We will have a look at the first question of exercise 3.1. First question is, given here are some figures, classify each of them on the basis of following: simple curve, simple closed curve, polygon, convex polygon, concave polygon. Okay, let us check it. First figure. This is a simple curve. Why? Simple curves are the curves that do not intersect itself at any point. So here you can see that this is not intersecting, the curve is not intersecting anywhere. So this is a simple curve, right? And what about this? This one again, a simple curve. What about this one? This is not a simple curve because two figures are given. So this is not a simple curve. Okay, this is not simple. And what about this one? This is again not a simple. Why? Here curves intersect itself at these points, right? Yes. So this is not a simple curve. And what about this one? This is again a simple curve. And this one again a simple curve. This one is also a simple curve. And what about this one? Here you can see that a line segment with circles on both the ends, right? So this is not again a simple curve because point in the circle and the line segment are intersecting at these 2 points. So this is not a simple. Now, simple closed curve. Which are simple closed curves? First one, this is again simple closed, right? This is simple and closed also. So this is a simple closed curve. This is again a simple closed curve. This is not simple, so we don't want to check it. This is also not a simple curve. And this one is again a simple closed curve. What about this? This is again a closed one. That is simple closed curve. This one is again closed. So this is a simple closed curve. Here this is not simple, so we cannot say that this is a simple closed curve. Okay. Then polygon. Polygons are the simple closed curve which is made up of line segments, right? So here this is a polygon because it is made up of line segment, right? This is also a polygon which is made up of line segment. This is not a simple closed curve, so we don't want to check it. And what about this? This is not made up of line segments, so this is not a polygon. And what about this? This is a simple closed curve, but it is not made up of line segments. This also same, that is, this is a simple closed curve, but it is not made up of line segments, so it is not a polygon. This also not a polygon. What about convex polygon? A polygon is classified into convex and concave polygons. So only we have to check the polygons, whether it is a convex or concave. So here this is a polygon. Is it a convex or concave? Here we can see that one interior angle of this polygon is more than 180 degree, right? So this is a concave polygon. Otherwise we can say that if we are considering the diagonal of this polygon by connecting these two non-adjacent vertices, then this diagonal lies in the exterior of the polygon. So it is a concave polygon. Okay. And what about this second diagram? Here all the interior angles are less than 180 degree. So we can say that it is a convex polygon. Clear? And if we are considering any of its diagonals, it would lie inside the polygon itself. Okay? The rest are not a polygon, so we don't want to check it. These are not either convex or concave. Clear? Question number 2. How many diagonals does each of the following have? First one is, a quadrilateral. Convex quadrilateral means a quadrilateral having all of its interior angles less than 180 degrees. So let us consider a convex quadrilateral. This is a convex quadrilateral. Let's name it as ABCD. Okay. Then we have to find the diagonals of this polygon, this quadrilateral. So what is meant by diagonal of a polygon? Diagonals of a polygon is the line segment joining any two non-consecutive vertices of the polygon. Here A and C are non-consecutive vertices. So we can form a diagonal here. So AC is one of the diagonal of quadrilateral ABCD. Right. And here B and D are also the non-consecutive vertices of this quadrilateral ABCD, right? So here we can form a line segment. BD is again a diagonal. So AC and BD are the diagonals. So how many diagonals are there in a convex quadrilateral? Thus 2. Right? Now question number B, regular hexagon. Regular hexagon means what? A polygon having 6 equal sides. Hexagon means the polygon having 6 sides, and regular means all of its sides and angles are equal, right? So we can consider a regular hexagon. Okay. Let's name it as A, B, C, D, E, F. Now what we have to do? We have to join the non-consecutive vertices of this polygon that will form diagonals. So let's start from the vertex A. So A and E are non-consecutive vertices. So AE is one of the diagonal, and next up AD, A and D are non-consecutive vertices. So AD is again a diagonal. A and C are non-consecutive vertices. Therefore AC is again a diagonal. From the point B we have to form a diagonal. So B and F are non-consecutive vertices. So BF is a diagonal. Then B and E are again non-consecutive vertices. BE is again a diagonal. B and D are non-consecutive vertices. Therefore, BD is again a diagonal. Now from the vertex C, B and C are consecutive vertices, so we cannot consider that. Then C and A, they has already formed a diagonal. Now C and F forms a diagonal CF, and C and E are non-consecutive vertices, again form a diagonal CE, and C and D are consecutive vertices, so we cannot form a diagonal. Next up, from D and C consecutive vertices, so we cannot form a diagonal. D and B already formed, and D and A already formed a diagonal. Now D and F are non-consecutive vertices, so we can form again a diagonal. So DF, then D and E are consecutive vertices. Now from E and F are consecutive vertices. E and A already formed, E and B already formed, E and C already formed, E and D consecutive vertices. Now from FA consecutive vertices. F and B already formed, F and C already formed, F and D already formed, F and E consecutive vertices. So how many diagonals we have formed? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 diagonals are there in a regular hexagon. Right? Then third one, C, a triangle. Okay. Let's ABC is a triangle. Then can we find the non-consecutive vertices for this triangle? No. If we are considering A and C, They are consecutive vertices. A and B are consecutive vertices. B to C non-consecutive. We cannot find a non-consecutive vertices in a triangle. So that we cannot form a diagonals in a triangle. Therefore, in the case of a triangle, the diagonal is equal to 0. Clear? And students, I want to tell you there is a shortcut for finding the number of diagonals of a polygon. That is, if n is the number of sides of a polygon, the number of diagonals of a polygon we can find out by n into n minus 3 divided by 2. Okay, now let us verify this formula in each cases. Okay, so in a quadrilateral, the number of sides equal to 4, right? So n into n minus 3 divided by 2 equal to 4 into 4 minus 3 divided by 2. 4 into 4 minus 3, 1 divided by 2, that is 2. Right? We got 2. There are 2 diagonals for a convex quadrilateral. So in the case of a regular hexagon, what will happen? N equal to hexagon having 6 sides. So n equal to 6. Then substitute the value in that equation. Then it will come 6 into 6 minus 3 divided by 2. That is 6 into 6 minus 3 is 3 divided by 2. That is 18 divided by 2. That is equal to 9. Isn't it? The same answer you are getting. And in the case of a triangle, n equal to 3. Then substitute the value in this equation. Then 3 into 3 minus 3 divided by 2. That is 3 into 0 divided by 2. That is 0 itself. So student, this is the easy way to find the number of diagonals of a polygon.